All right, in this lecture, we're going to talk about sources of geologic information. So a lot of the time, we need to go and find some kind of a map where we want to look at what is the surface geology at the site. Maybe we're going to go out and do some drilling and sampling. But before we do that, we want to know as much about the site as we can. So there's a lot of information out there that's widely available. There are also mapped hazards for landslides, liquefaction, earthquake faulting, and so forth. And some of those maps are really important for us because it may have a direct impact on some of the things we have to do during our site investigation. If you're in a zone of required investigation for liquefaction hazard, for example, there's specific things you have to do in your site investigation in order to satisfy these requirements. So what I'm going to do is come in here, and just Google California Geological Survey Zone Required Investigation. Okay, I've already Googled it before. So it'll pop this up. Conservation.ca.gov is the California Geological Survey website. So you can go there, and then you'll see they have these seismic hazards and zones of required investigation. There's the Alquist-Priolo Act. That's a law that requires us to look for earthquake faults if they happen to be within the Alquist-Priolo zone. And if you do find an active fault, we're prohibited from even building new structures on it for occupancy for people. Similarly, for liquefaction zones, you have to do some investigation. And then for landslides, maybe you have to do some mitigation. So you can get these maps if you go to the CGS's warehouse, and then you click here, Regulatory Maps and Reports. It'll open up this little ArcGIS web server. I'm going to click OK. And the California Geological Survey does not have maps covering the entire state of California. It does have maps in the more heavily populated areas. And so all of these little squares on this map of California show you where they have these hazards mapped out. And the red and blue ones have more complete information, the yellow ones less complete. So let's just zoom in here on LA. And what I'm going to do is pick the quadrangle that has UCLA in it, which is this Beverly Hills quad right there, zones of required investigation, PDF. You can see there's a PDF file that you can download. It's a pretty big file, like maybe 50 megabytes or something like that. There's also this zip file that has GIS data in it. It's actually ArcGIS data, not QGIS data. And then there are some reports here too, where they tell you how they looked for faults, seismic hazard zone report, and so forth. So I've already downloaded this PDF. I didn't want to wait during the lecture for it to download. And I've also downloaded the GIS data product too and opened it in QGIS. So what I'll do first is show you the PDF, which is this one here. And you can see that there are maps. Well, here's the map. It shows the roads. You know, like here is, what is that, Interstate 10 right there and the 405. Here's UCLA. And then there are these colored regions. So if we zoom in on the legend, over here, there we go. You can see that, okay, the green zones are liquefaction zones. That doesn't mean that liquefaction will happen in that zone if there's an earthquake. What it means is that there's reason to suspect that there may be liquefiable soils within the zone, and when you do your site investigation, you have to look for that. You can't just go and do your site investigation and, not say anything about liquefaction. It may be that you don't find any liquefiable sediments there. Okay, it might all be really stiff clay and it's just not going to be an issue, but you do have to look for it. Similar for landslide zones. It doesn't mean that landslides are going to happen everywhere, that there's a blue hatch region or a blue shaded region. It just means you have to do some extra work. Then there are these earthquake fault zones in yellow. And then there are overlapping areas that you can see down here that are kind of a mix of the different colors. So let's come back to this map and take a look at UCLA. And what you can see is that, let's see, here we go, there's UCLA. There is a little bit of liquefaction hazard zone here at the bottom. There's LeConte and Gailey, so at the very corner of campus, there's a little bit of a zone of required investigation for liquefaction. I think the In-N-Out Burger is within that zone somewhere too. Okay, so that doesn't mean that you're going to see this whole corner of campus liquefy if there's an earthquake, right? It just means that if you do build something there, you have to look for it. Similarly, up here near Sunset and Veteran, there's a little zone, a little liquefaction zone. There's a tiny little landslide zone right there too, up by Sunset Rec. So you can see that we do have some of these geologic hazards on campus. If we go a little bit north up into the hills of Bel Air, you can see much more landslide hazard. The blue zones tend to be on steep terrain, and then so right here there's a green zone right in between the two blue zones. Well, what's happening there is that the hills are eroding away, right, and all of that sediment is coming down and getting deposited in this drainage. So the green zone is like a low-lying valley in between the hills, and it gets filled up with sediment that's pretty young, and young loose sediments tend to be more susceptible to liquefaction. So if you're up in this zone, there aren't very many spots where you aren't either in a landslide zone or a liquefaction zone, right? So it's hard to find places. And then you can see down here it kind of transitions out, and then you reach the basin or the flat part, and then there's really no more landslide hazard once you get down here because the ground is all flat, right? There's nowhere for it to go. Okay, what you see here in yellow is a fault rupture zone. And this is the Santa Monica Fault. So it runs right along here, maybe even connects up with this one, but and then you can see part of the Newport Inglewood Fault down here. So what these zones mean, this is actually pretty important because the law actually requires avoidance rather than allowing for any kind of mitigation. If you map in one of these yellow zones, you have to do a fault survey. So you have to hire a geologist to come out and look for any sort of active fault trace. If they find an active fault trace, you're not allowed to build within some number of feet of it. I think it's 50 feet or something like that. So if you happen to have a fault, an active fault that runs through land that you just purchased to develop a new building, you may be out of luck because you can't just build deep foundation or big foundations and mitigate against it or anything like that. You have to avoid it. So I think that that's kind of unfortunate. I think there are things we can do to mitigate against surface rupture. But right now, the Alquist-Priolo Act doesn't allow us to do it. And the reason is pretty simple, right? If a fault rupture goes through a building, it causes a lot of damage to it and could be a life safety hazard. So anyway, that's these maps. And they're really important for us as geotechnical engineers for planning our site investigation. Notice if you come down here to the beach, right, there's the ocean. The whole beach is basically a liquefaction zone. You have sand there, it's saturated, it's susceptible to liquefaction. All right, now let's take a look at QGIS. It's nice to have this PDF file, but if you ever wanted to make your own figure to put in a report or something like that for your specific site, you'd probably want to go to this route where you start downloading the actual data files themselves. And these data files are much smaller in size. So you know, instead of being like 50 megabytes, this QGIS or this GIS product was only 200 kilobytes or something like that. So instead of being this big raster set of pixels, it's a vector. So you're defining these layers in these regions. So the coloring is a little different here. Actually, you could recolor this if you want. I haven't done it, but the pink zones here are the landslide zones, the gray zones are liquefaction, and then actually yellow, the yellow zones stayed yellow. So those are fault rupture zones. So what you could do now is first download a base map. So this map underneath it is a hillshade base map where you can really see the topography. And now you can see, right, all of these hills over here, and the pink zones are right on top of the mountains. I mean, it's really obvious now. And then you can even see these drainages in the middle right there. Those are clearly in these little valleys between the mountains where all of the sediment goes. And then you could add more layers to this, right? You could have like a layer that has your site right there or wherever it is. And it's a nice way to integrate everything together. All right, so for your homework, you're going to need to go and start working with these maps and just look at whether a particular site of interest to you lies in one of these hazard zones. Now, it's not really cause for alarm, right? You can see the hazard zones are pretty big in Southern California. It's not necessarily that you're at risk if you lie in one of these zones. It's just that you'd want to be careful about, understanding the hazard that you face if you are, in fact, in one of those zones.